Ia să te calzi, că la... Hello there, I'm Thomas Hatsios, German America Pal, flying the Boeing 787-900 United flight from Zurich International Airport. We're going to be flying Zurich, Switzerland, Germany, then come back to the Zurich International Airport, runway 14, For an ILS localizer landing zone, I'm in the cockpit for the pre-takeoff preparation of the quality wings of Boeing 787-900 and Microsoft Flight Simulator X. I'm gonna start showing the cockpit instruments displays and the functions of the Boeing 787-900 jet aircraft. I'm gonna start with the primary flight display that displays the airspeed indicated, the airspeed selected from the autopilot flight vector system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the vertical rate of climb descent of the aircraft in 10 times feet per minute, or the stiffness of the trigonometric angles and decrease in climb descent. We have also the altitude indicator with the artificial horizon, the pitch ladder in decrease, and the bank angle in decrease. Also we have the ILS localizer, the instrument landing system of the airport runways we use for takeoff and for landing. So we have the threshold antennas that transmit the radio frequency that is received from the onboard antennas of the aircraft, so we can align with the horizontal localizer and vertical glide slope the angle of approach. We have also the ILS localizer crossbus displayed in the primary flight display. We have to tune a unique radio frequency each time we take off and we land from a different runway and airport for a given also runway heading for the ILS localizer to be aligned both horizontally and vertically. So we can tune this either manually from the radio management panel or selected from the flight management computer when we create the flight plan later. I'm gonna show you how to use this planner, the flight plan, to create a flight plan and also select the ILS localizer for approach and landing. So we have also the flight director course was displayed for manual guidance of the aircraft, and the autopilot course was displayed for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies, and the flight mode and 0 with the autopilot and the auto throttle later on vertical navigation modes. We have also the HSI, the horizontal situation indicator with the magnetic heading and track. They did create the display of the flight plan. We're gonna use a flight plan using the flight management computer over here. We'll input all the data that we need to create a flight plan. Is gonna be followed either manually or automatically. When we fly, we can connect the autopilot, so you will see from the flight management computer inputs. We're gonna create a flight plan that is gonna be displayed with the purple or magenta line here in the navigation display, and also in the HSI, and also in the navigation vertical display in the horizontal, both of them. And now we can connect later the autopilot here, autopilot flight director system panel with the modes that you see. So we have also we have the navigation display. The navigation display that displays the GPS position of the aircraft. We can see the magnetic north pole, the geographic north pole, the magnetic variation depending on where we are in the world. We have also the terrain and weather reflections from the weather radar. You can see the red, green, yellow color difference indication depending on the distance the aircraft is away from the terrain, and also the altitude difference. You can see also the sea lakes and rivers with blue. We can see the airports where they are located on the airport, the runways and the taxiways. We cannot use the runways for takeoff and for landing, the runway length and heading. And also we can see the airport maps. You will see later when we create the flight plan is going to display us the map of the airport. We have also the navigation aids, the navigates which are the workstations, ADFs and DBs are the waypoints which are horizontal vertical navigation fixes and altitude and airspeed constraints. We're gonna have to fly through some waypoints during this flight when we select the flight plan. We have also the display of other aircraft that fly around our own aircraft using the transponder, the airspeed, ADC, transmitter, receiver, transmitter radio frequency to other aircraft, and now the air traffic control and receives from other aircraft. It will display, it will calculate where the other aircraft is positioned, the distance from our aircraft, also the altitude difference. It will also calculate whether the other aircraft climbs or descends with respect to our aircraft, and also the velocity closing in between our aircraft and the other aircraft. It will give us a warning from the TCAS system, the traffic collision advisory system, if we have an incoming collision in the air. We can see with the diamond shape the other aircraft where they allocated the distance from our aircraft up to 14 nautical miles or 72 kilometers in a 360 degrees radial around the aircraft. Also, we can see other craft in the runways and the taxiways when we are in the airport, in the ground, in the airport. And so we can see also we have, this is for the navigation display, we have horizontal, vertical. We have also other things to see before we go into takeoff. I will show you all the systems that I can, as much as we have time, before we go into takeoff. So you will see also the flight controls of the aircraft. You will see the setup that I have, the computer here that I use, also the keyboard and the mouse pad here. Also you will see for the flight controls I have this side stick over here, the Lszh Extreme 3D. So I would use the side stick to control the aircraft flight controls, so we can climb or we can descend, we can make turns to the right, to the left. Also use the rudder pedals, make left and right turns, as you can see. Also we have the thrust levers over here. You can actuate the thrust commanded from the engines as we increase or decrease the thrust levers position back and forth. It takes like a couple of seconds for that to react, so we need to anticipate in flight. So you can see if we apply full takeoff, it will give us a warning that we're not configured for takeoff. The ducks there. Okay, so we can fly the way we want, use the flight controls also. So we have also over here you can see the thrust levers, left and right engine. Thrust lever, we have the fuel control to the left and the right engine. We have the fire extinguishers, pull out and switch for the left and the right engine. We have over here you can see using the thrust levers, as you can see, and the flight controls are the thrust levers over here position, the side stick. So we can actuate back and forth the thrust levers position for the thrust needed from the engine. Also the horizontal stabilizer trim function, how you use the stabilizer trim when we fly. Also the auto trim function for the aircraft. So you're gonna see many interesting things. You can see the thrust levers position. You can see we have the auto throttle over here, the thrust reverse for the engines. Over here pull back, the auto throttle disengage switch, the takeoff ground switch. Also the speed brakes over here, extend and retract the flaps position. We can set the flaps the way we want when we fly, before takeoff, before line, how many degrees we need them. As you can see now they're fully extended, like 30, 35, 20 degrees. So you can see the degrees the flaps are extended or retracted over here in the multifunction display, or the ACAS, engine indication and quality system display over here. So we have the display of a lot of information. We have the engines, left and right engine over here, as you can see. The flaps position, landing gear, extend and retract, the auto brakes over here, executive takeoff, for landing also, or disarm. We have, as you can see, the stabilizer, the horizontal tail trim, stabilizer trim, the rudder trim. Right now it's 4.25 degrees, this horizontal tail. You can see the horizontal tail here. We have the left and the right horizontal stabilizer. and the trim function for the elevator also. The rudder is 0 position. You can see the cabin pressurization, also the outflow valves. So this is the pressurization. Also in many aircraft receives pressurizer from the left and the right engine, high pressure. Oh, we have an aircraft, a Boeing 737, just came in for landing, as you can see. So we're gonna see all these things. You can see the displays. You can see stabilizer trim, the outflow valves, pressurization, very important. Wouldn't fly at 45,000 feet. The pressure will reach 7.8 psi inside the cabin. We have automatic right now, so the manual is displayed with a number. We have also the gross weight for takeoff, total fuel on board, and the fuel temperature, and this is the regular temperature. You can see the engines, left and right engine. Also, you can see here the primary flight display and the navigation display. We have all the information that we need. Now we'll talk to you about now the stabilizer trim, left and right, and also I will talk to you about the outside view, what we need to know for flying the aircraft. So you can see the stabilizer trim here. We have over here you can trim. Over here you can see we have the control wheel of the aircraft, the flight controls. So you can see the control wheel. We can move around to make turns right or left. As you can see, very easy, very nice. The 3D view of that, as you can see. So we can make left and right turns. We can pull back and forth like this, and also we can use the stabilizer trim, these switch. This way we can trim the elevator up and pitch the aircraft nose up. We can trim the elevator down and pitch the aircraft nose down, as you can see. So the tag says over here elevator trim, left click down, right click up, as you can see. Elevator trim, left click down, right click up. So this is how to trim the elevator in flight. It's pretty much the same in all aircraft. You trim the elevator, you balance the aircraft in flight, and you can even fly with the hands off. Also trim down. You can see how many degrees you trim up or down the elevator. We have the autopilot also disengaged, the head-up declarer, the flaps position over here. So this is the control wheel of the aircraft, as you can see. Also the control column for the elevator for climb, descent, make turns right and left. We can see also here the trim position. We have changed a little bit now. It's 4.5 degrees. You can see the green button is for takeoff limit, and also the white band is the maximum nose down and nose up limit. Also we have another one here, the alternate switch for the horizontal trim stabilizer. As you can see, we can use this stabilizer trim. So this way you trim the elevator up, this way you trim the elevator down. We have also the cutoff switch for the horizontal stabilizer, left and right. You can see the fuel flow for the left and right engine, the thrust levers, left and right engine, the flaps position over here, the speed brakes, the parking brakes set, also the flight management computer and the mouse pad for the flight management computer. So we have over here, you can see stabilizer trim. You can trim the elevator up and down this way. Trim elevator up, nose up, aerodynamic effect in flight, as you can see, and trim the elevator down. You have the nose down. So this is very easy to remember how to use this switch, trim up and trim down. Also we have the parking brakes over here, the stabilizer trim, the cutoff switch, the radio management panel, fire extinguishers, left and right engine, transporter, the rudder trim. Over here a radio communication panel, some other instruments. We need to know high frequency, satellite, very high frequency, communication, ground proximity transporter. So we can see how many degrees, as I tell you again, maybe a little bit different now, 4.5 degrees again, no difference. So if you look outside, you can see how you use this instrument, the stabilizer trim left and right, horizontal tail elevator, and also stabilizer or elevator trim function, also the rudder left and right turns. I will talk to you. You can see also the rammer turbine over here. No, actually it's the APU, the auxiliary power unit, we have over here. So you can see the auxiliary power unit, the APU. Over here we need to start the engine later. It will give us pressurizer and electric power to start the engines. So I will talk to you now about the aerodynamics. We need to know for flying the aircraft, Newton's physics, aeronautical engineering, and also we need to know the air transfer pilot license theory and the commercial pilot license theory, aerodynamics and flight dynamics, Newton's physics, and bringing theory of fluids, some principles. So I will show you the outside view of the aircraft, and I will talk to you how the aircraft is actually flying. So you will see now also the flight controls again. So you see here from the outside view. So you can see the surface area of the wings when the aircraft will be flying later. We have the aerodynamic flow. When we fly fast, moving fast the aircraft, it will give us aerodynamic lift. Over here it acts where the center of pressure is, pretty much close to the engine, so we will act over the weight. It will make the aircraft fly up into the air. So we have below the wings, you can see it's more flat. So generally using the burning theory of fluids, the airflow is moving slower, so we have higher pressure, which will pressurize the aircraft wings up into the air. Also the top, we have lower pressure, will create a lower air pressure suction above the wings. So there is differential pressure below and above the wings. Also we have the thrust vectors from the engines. That puts the aircraft forward. We have the jet engines, jet blast. We have the fuel flow over here, fuel booster pumps from this section. We have the left and the right wing and the center tank, fuel tanks over here. So you can see we have the jet engines over here. You can see we have also you can see the bypass from the front fans over here, bypasser. Because we have the high pressure compressor and turbine over here and low pressure compressor and turbine in the front, and also we have low speed starter and shaft and high speed starter and shaft, the exhaust nozzles. So we have two flows, one from the bypasser, which is lower pressure, maybe lower speed, and the high pressure, high speed. We have the thrust reversers over here also. So we have the fuel flow is coming down for the engines. We have also wing and engine guard the ice. We have pressurizer from the engines is coming in for the hydraulic fluid tanks, pressurization, cabin pressurization, oxygen. The systems, wing and engine guard the ice over here also from the manifolds. So we have the mean aerodynamic chord position here where the maximum aerodynamic lift occurs, 33% of the Mach. Also the center of gravity is coming down here. We have the center of gravity. We have the yawing axis over here. We can use the nozzle and the rudder in the ground to make the aircraft moving around the yawing axis to make left and right turns. So in the air we have the rudder for that, and in the ground we have the rudder and the nozzle together. So you can see the rudder pedals, what they do when we move them. Left and right rudder pedals is to control the rudder in the air, and now the nozzle with the rudder in the ground. And also we have the toe brakes. We have also the tiller, left and right tiller over here. So both rudder pedals move together, are interconnected. So the tiller is only for the nozzle. So from 0 knots up to 45 knots or 72 kilometers an hour, the nozzle will be deflected automatically from the computer. From 0 to 76 degrees left and right turns. Also above 45 knots or 72 kilometers an hour, the rudder becomes aerodynamically effective, so the computer will limit automatically. You don't need to do nothing when you press the rudder pedals from 76 degrees the left and the right down to 7.6 degrees the forward nozzles over here, as you can see. Also, when we increase the airspeed above 80 knots or 144 kilometers an hour, the rudder becomes more aerodynamically effective, and also the computer will limit automatically. Will lock the deflection of the forward nozzle to 0 degrees or half 1 degree. So this is how to control rudder pedals, the rudder and the nozzle control. And the brakes, we have the toe brakes also. When we land, we have first the rudder, and then the nozzle will be activated as we slow it down. So we have also one more axis here. It's from wingtip to wingtip. Is the pitch axis over here in the Airbus. You can climb and you can descend back and forth, as you can see. So this way we climb, you see the elevator up. This way we descend. In the Airbus is side stick back and forth. In the Boeing is the yoke back and forth like this. Same principle, same function, no difference at all. Take the weight up, climb, take the weight down, descend. Also we have one more axis from nose to tail over here. Is the longitudinal axis, is the side stick left and right in the Airbus. Ailerons and spoilers, as you can see. Is ailerons, spoilers and flaperons in the Boeing. Is the control wheel instead of the side stick. Same function, no difference. You can see also all speed brakes are ailerons now. And also the flaps are extended. The speed brakes are the flight spoilers. So you can see left and right control wheel over here. Same thing like the side stick left and right, no difference at all. Also we have the stabilizer trim. One fly we need to apply together, and now the rudder pedals. So we have a few more minutes for this to finish the video. So you can see, so this is all for this side of the flight controls. So I'll show you one more view of the flight controls, and then we go for the rest of the systems before we go into flight. So you'll see another nice view. Hope you're gonna like it. You can see also here again the computer, the side stick, and also the screen, maybe a better view. So you can see we can climb, we can descend. Same thing, like make left and right turns, no difference like the Airbus and the Boeing. No difference in the flight controls function. So we climb, we descend, make turns. You can see also another aircraft is coming over here for landing. Comes Boeing 737-800. So this is the main principles. Also the thrust levers, as you can see, actuate the thrust levers. So you can see we have this side stick is identical to the Airbus flight controls. When flying, climb, descend, make turns. Hope you like it. And now the thrust levers control. So this is also the outside view. One more view over here. So we can climb, we can descend like this, make turns, rudder, left and right, also ailerons and spoilers. Same like the Airbus side stick, no difference at all, as you can see. So now we go for the rest of the systems. This is enough for the flight controls right now. Hope you like it. Now we go for the flight management computer. I will input all the data. We need to create a flight plan. we need for flying this aircraft to make this flight very fast and easy, as you can see right now. So I will use again the keyboard over here, the mouse pad I need for this display over here of the flight management computer. So we have the flight management computer over here. We can use through this mouse pad, and the keyboard, the numeric keyboard, and set up over here from the screen. As you can see, all the data. We need the modes from the flight management computer. So I will show you a better view right now, a little bit better. So you will see from this view over here, I'm gonna set up the flight management computer. So we have identity, position, performance, takeoff, flight plans. So we have identities, Boeing 787-900 GNX engines. Index position, we can set the inertial reference, IRS position for alignment with laser gyroscopes and the GPS receivers of the aircraft, and also the magnetic north pole. Performance, you can see zero fuel weight, fuel on board, and gross weight for takeoff, reserve fuel. We're gonna set later. I've set first the origin and destination, Lszh airport over here. Departure and arrival. And we set the runway 14 over here. So we have departures and arrivals. Select runway 14. Trans the Zui over here. And arrivals, runway 16. We can select runway 16 to 834 ILS 14 ILS 16. ILS 28 ILS 34 GLS 14 localizer 28 localizer 34. So we select ILS 14 Trans Amiki and Trans Negria 1 Alpha. So we have departures and arrivals set. We have the route is displayed with blue, it's not yet activated, so we can see the first waypoint after takeoff, second, fourth, as we're gonna fly. Use also the autopilot if we need. Then descend, approach, and landing over here. So this is the route. We use reserve fuel on board, and gross weight for takeoff. Cruising altitude 25,300 feet, cost index 100%, fuel freezing temperature minus 37 degrees. So we can press the execute, it will activate. Over here you can see this green switch, it will activate with purple and white. We have the flight plan created, first waypoint after takeoff. Make a left turn, Zui 6 nautical miles, 246,000 above the sea level. Then Negria 071 heading, 26 nautical miles from Zurich, 240 nautical miles per hour, and I believe the altitudes are should be a little bit different. Then descend, approach, and landing here is back to Zurich Zig 701. Also runway 14 approach and landing over here along with the runway. So we have flaps for landing 15 degrees. Center of gravity trim 23%, 4.25% degrees. V1 we rotate, V2 gross weight for takeoff. What is runway positions? We have route, departure, arrival, alternate, VNAV, progress, hold over waypoint, high flight, legs, the legs of the waypoints, and the navigation radio, tune ILS for ABF. So we go back over here to the virtual cockpit, and we have so we have about 30 minutes more, approximately, I believe. We need to start the engines right here. So you can see over here the flight plan we have created. So you can see over here the airspeed of the altitude above the sea level. So I'm gonna show you now how to start the engines over here. Start the APU. Gonna start the APU. We have the left and right IC, the great drive generator, 180 to 200 volts for 100 Hz frequency, the battery, primary flight control computers in the auto position over here, air data computer, flight control surfaces, battery, down power, FT door, window sheet over here, rammer turbine, left and right engine driving, primary demand, hydraulics over here. So we have the wing and engine RDIs over here, pressurization over here, left and right engine pressurization. We have also um, the fire extinguishers over here, the car engine, electronic engine control for the engines, left and right engine with the auto start, fuel jettison, get dump some fuel in flight, fuel on board, left and right engine, fuel jettison and balance also. So this is the main components over here. We need to know. So we have a few more minutes left. We need to start the engines very quickly. So I believe we have the engines modes over here. The systems. You will see the systems here in the display. So we have hydraulics, APU, oxygen, liquid cooling. You can see electric, left and right engine driving the APU. Also battery, main battery, voltage, charge and discharge, average. Hydraulic pressure over here, left and right engine driving. Also 5100 psi, the pressure and the quantity of the hydraulic fluid. Shuttle valves, oscillation valves, where the hydraulic fluid goes, which systems use hydraulics. Fuel on board the aircraft, left and right wing and center tank. Also crossfeed valve is off with an electronic feed other engine with other palm arrival tank. So you can see low and high pressure fuel valves, also the APU. You can see the FAREX that control the engines, left and right engine, also control the transfer of fuel from the left and the right wing into the engine components to heat up the fuel in flight. When we fly at high altitudes, the fuel will freeze. As you can see, minus 37 degrees is the fuel freezing temperature over here. So we recirculate the fuel to heat it up. Also the minimum fuel temperature right now. So we have also the APUs fed from the left wing using the DC motor, pressurizer from the left and right engine. The doors are closed, the cabin can be pressurized, the gear, pressure of the tires and flight controls also over here. Moving the flight controls like this, one of the last things we need to know before going to flight. You can see the deflection of the flight controls, the tail also, the rudder pedal face display over here, maintenance systems, circuit breakers over here. So we have the checklist, what to do before start, after start over here, descent, approach and landing. We have navigation display again. So we need to restart the engines. We're gonna turn off both engines and restart them. So both engines in the off position like this. So you see the message, the engines are off like this. Also you can see from the outside. So we need to go over here in the overhead panel and set up the auto start very quickly like this. So you can see the yellow reconfiguration is for starting the engines. The auto start is coming in, as you can see. So we have pressurizer right now from the APU, from the auxiliary power unit, to start the engines, both engines. So we have above 24%. We can start the fuel flow in the round position, as you can see. So the auto start is coming in 25%, 27. So we have both fuel, we have the auto start on. As you can see, the messages will go off in a couple of seconds, above 50%. The hydraulics are on, and above 61% we can go. We have running engines, so we set flaps for takeoff, speed brakes arm, also here this, and we need to set up only the autopilot right now. So setting up the autopilot, auto throttle, left and right, the airspeed over here, we're gonna set it. We have LNAV and VNAV like this, the auto throttle, the flight director off. We can not rearm the modes, autopilot like this, disengage, bank angle and limit, and also the heading. We're gonna set the heading of the runway we're gonna use for takeoff and for landing, 136 degrees. Also vertical speed like this, descent, like this, climb. Also we can use the altitude, thousands, 25,000 and 300 feet. So we're gonna take off right now. We're ready for the taxi and takeoff. So parking brakes off, take the clearance from the air traffic control. So you can see the runway is open for us for takeoff. So we align only with the runway, and we have like 15 more minutes left for this flight. So this is Thomas Hatsios, the German-American pilot flying the Boeing 787. We just started the takeoff, so stay with me. I have to align a little bit more. So I have to stabilize the engines first at low setting, like 40-50%, then advance to full takeoff. So here we are, 100 knots, 120, 30, V1, we rotate, we pitch 9 degrees for the takeoff rotation, and landing gear up. We have positive rate of climb. We can leave the hands off from the side stick, no problem, as we're climbing, as you can see. So we keep climbing over here. You can see we have the terrain around in front of us. In the display, terrain red, green, yellow. We are 1,000 feet above the ground, but 2,000, 3,000 feet above the sea. As you can see, there is a difference between the elevation above the ground and above the sea level. You can see the airspeed is 250 knots right now, so we can climb faster. We are 2,400 feet above the ground, 4,000 above the sea. We climb with 5,000 feet per minute. You can see the pitch altitude, the wind direction and speed, the flight plan we need to follow, the engine's indication. So we need to use a little bit less over here, the flaps. So we can see we are like this above the ground level. So you can see how many feet we are above the ground level as we watch the airspeed and the altitude. We can see here the green is the terrain around us, and also below us this green wave is the terrain. We are like 6,000 feet above the terrain right now. You can see 6,000 feet above the terrain. This is the aircraft symbol as we climb. So we can see also from the outside view. So now we need to make the turn over here. You can choose the head-up display. So we have maybe like 10 more minutes left out for this flight. It's a small flight. As you can see the cockpit after takeoff over here. You can see we keep climbing. So here we are, we can see the aircraft, the Boeing 787 as we're climbing. We need to cross through these waypoints over here and then come back for landing across the purple lines over here. So we're gonna cross through these waypoints as you see as we fly and then come back for landing. We have to cross through both the purple color indications, also follow the autopilot. You can see also the head-up display over here. The autopilot settings, the engines. Maybe we need to retract some flaps, fly a little bit faster. So you can see our position right now. You can see around the Switzerland as we're gonna be flying. Also the Germany, my homeland, in front of you, the France. Gonna be flying closer. So we need to follow over here, and we have 11 more minutes to go back to the airport as we fly through here. So we need to be aligned. We're gonna use also some rudder pedals for alignment as we turn. here we are aligned with this area, which you can see. We're flying very close to the lakes over here. Also the Germany, Bayern Munich in front of you. So we have the lakes, the France, the Switzerland, and we need to start the turn now. So we start a manual turn like this, keep climbing a little bit maybe. And we have less than 10 minutes to go back, as you can see. So this is how we turn over here, overflying the lakes of the Bayern Munich, my homeland. This is the Boeing 787. Need to be aligned with the flight plan over here. So we can fly manually right now. (21,000, 22,000 feet), and we have a few more minutes to go back. You can also set up the autopilot if we need fly manually like this. So we need to override here, go back to Zui like this and set up the autopilot and have more airspeed also. So now we're going back home with the autopilot connected, as you can see, the CAP on. We need maybe to start the descent right now. We have the chemtrails like these, very beautiful chemtrails. Hope you like them. Here's the frozen vapors, as you can see, from this beautiful aircraft, and we start the descent right now. So to start the descent, since over here, since the altitude and also the airspeed a little bit give us more amplitude for descent. So we start descending like this. As you can see, so we have the autopilot connected and we descend, as you can see. And we have 5 more minutes to go back to the airport, as you can see, as we are descending using the autopilot connected over here. AP on, you can see AP on also here, autopilot connected. So we need to disengage the autopilot, fly maybe manually like this as we descend. We have a few more minutes to descend back to the airport. You can see the arc of descent over here as we are descending. We're gonna use the speed brakes to slow down. We are a bit of overspeed, also a little bit higher than it should be. So now we're gonna start the turn over here for descent, approach, and landing. As you can see, gonna descend, follow this flight path over here, and we have like 4 or 5 more minutes for descent and landing. We use a little bit left rudder over here to align with the runway a bit faster. Add a little bit more thrust over here when we need. So we have a couple more minutes left for the landing over here. Need to be aligned with the runway at the right altitude. You can see also here the flight plan we need to follow for descent and approach. So we need to be aligned a little bit more with the runway. As you can see, we are closer to the runway position. We need to be over here. So to be fully aligned, we need also to be a little bit to the left as we are descending, as you can see. We need to add a few more flaps also. As we descend, make a little bit left turn and then right turn as we are descending. So you can see we follow the correct flight path. You can see also the Lszh localizer over here as we descend. We are into the runway position above the glide slope, both sides, as you can see. So we're gonna make a full manual landing right now. We need only 1 minute to land this beautiful airplane. As you can see, this is the runway we're gonna land in front of us. So we have a few more seconds. We have some side wind, some wind gusts. We need to grab like this the airplane as we are descending. Also use a few more, a little bit more less flaps, 35 degrees, not 30. So we are almost reached the altitude. We have a couple more minutes to go down for approach and landing. As you can see around you. So this is gonna be a very beautiful landing. We have some side wind, some wind gusts. We need to use cross control when we have side wind and wind gusts, as you can see. We need also to follow alignment with the runway, also 2 reds and 2 whites, the lights of the runway, as you can see. Here we are, a little bit lower altitude, increase the rate of descent a little bit, then leveling off with the horizontal tail for the flare over here. So gonna be flaring, as you can see. We have the flare, very beautiful flare and touchdown, very professional, very smooth. So we use parking brakes, idle thrust over here, and thrust, full thrust reverser over here, slowing down the airplane to the runway, as you can see. Very beautiful, very professional. Thrust reverser, here we are, just made it, and a very beautiful center line. So this was the Boeing 787, as you can see. So we are fully stopped. You can see all our landing gear here is fully safe. Every bit of the landing gear, nose wheel over here. You can see all wheels, tires. There is no breakages, no broken parts. The aircraft is starting up the way it should be in the runway, with its wheels over here, and also the nose wheel from the walk around, as you can see. This nose wheel is very beautiful, as you can see. There is nothing broken here, no single metal part or tire. So you can see also how we are loaded over here. You can see how much runway we have left, how much we used. We are fully center lined almost. So this is the Boeing 787. So that was Thomas Hatsios, a German-American pilot, flying the Boeing 787-900 tonight flight from Zurich International Airport back to Zurich International Airport with just ladder. We made a very beautiful and smooth landing. We'll show you a couple more instruments before we complete this flight tonight. So I will see you in the next session with the Boeing 787 900 Dreamliner aircraft, the beautiful Boeing aircraft. So you can see here we have the thrust reverse over here. We can cancel the thrust reverser, or we can deploy it again if we need, like this. You can see thrust reversers up. You will see the blocker doors are open like this. You can see also the thrust reverser over here is displayed in the navigation, in the engines display. We have the autopilot here to reset like this. We can see the airspeed, the altitude, the vertical speed, radio altitude, navigation display, a few more instruments I forgot to mention. Over here, disconnect the auto trim function. So you can see also the engines here. The N1, which is the low speed status, have low press compression to one of the 200 engine exhaust custom turn to which is high speed status have high press compression to one of the 200 engine fuel flow, the pressure, temperature, quantity, and the vibration of the two stage.